Okay, so let me 1 second. Let me show that. Okay, so yes, hello. Yes, yes, I have done that. Yes. Okay. So here, if you, oh, this is not the confusion. Wait, wait, wait. This is the confusion matrix. Give me a second. This is classify 1 second. Mhm. 1 second. Okay, yes. Yeah, this is the one. Okay, so if we want to find a score in terms of 1 to 9, okay, so it will take between 1 to 9. So we must first have the data in terms of y test versus y spread. Okay, so this you have to take this. There are multiple ways of finding the score. Okay, this R2 score is one way where we will have y test. What is y test? So this is decision tree where we have not divided. So first of all, you should have data in two form. Okay, one is test, which is the actual data. This is the actual real case. What is this y-pred? This is the predicted data from your algorithm. Your algorithm which has predicted the value, right? That value. So these two numbers should be of same size. If there are 10 values here, this should also have 10 values. Then you can check. So let me see where we can apply. One case we'll see. Maybe polynomial regression will apply. Okay. So, or we can apply it some other place. Multiple linear regression data. Okay, so this data we can apply. Okay, so this is our multiple linear regression where this is data.csv. We are taking all this data and then this is our predicted output. Okay, here I will paste our code where this will be ypred, which is the predicted output from our algorithm. What is this y test? Y test is this data. Okay, so y test and x test. So x test and y test are the corresponding x versus y. Okay, now when I pass x to my algorithm, it will give me a new y test which will be slightly different. So that y test and y spread we are trying to compare. Okay, I will put a print here. Okay, now I will run this. Okay, so this algorithm is giving me a value of 0.9325. Okay, so this gives us a value which is telling how close my data is. So it is giving me some 93% accuracy. Now instead of all the values of -1, I will be taking, say, second value, second column, and in steps of 5. So only one range will come. Okay. Now if I run this, let us see, accuracy should fall down from 93 to lesser it should become. So it became 26. Okay. Now I have taken out of 4 columns, I have considered only the second column. Okay. Now what I will do next? I'll take the 0th column. Okay. Let us see for which column it gives more efficiency. Okay. 0, 0th column there is 90%. That means only one column is having a bigger impact. Okay, this column 0 has very big impact. Okay, column 1, column 1 has lesser impact. Okay, column 2 we already saw. I think there is one more column, 3, I guess, up to 3, 4, right? Total 4. Yeah, so fourth column is having least impact. Okay, so maximum, see, if you had done a simple linear regression and you tried, you would have got 90% efficiency. Okay, but you should have selected column 1. Okay, now because of multiple linear regression, it has given you all the other values. Okay, how different values are getting impacted. Now let me take all the cases again and just finish. Okay, so this will take all the values. Now if I run back, we should get again 93%. Okay, so this says that tomorrow if you want to guess some prediction, you are like 93% accurate. So it's a call which we generally take. Okay, so whether 93% accuracy is sufficient, then we can go with that particular decision. Okay, this is the code. I want you guys to apply it in any one of your algorithm. Anyone, try to, so make sure you have y test and y pred name and all are present. At the end of the code you can put and try. Quickly try. I am just sharing it in the chat. I have shared. You guys can try it anyone in any one of your code. Okay, next, hopefully you guys are working on that analog design which I have given. Okay, so if you are stuck, what you can do, if you don't know how to find out power consumption or anything, you guys can let me know, because in another 15 days, 10 days, I guess, you have to submit it. So don't wait at the end. Okay, because I think that is what your HOD is going to evaluate. Okay, whatever I have teach, nothing is going to matter. You are at the end you have to complete that, and also one machine learning algorithm which you have to complete. Okay, so maybe 10th I will give you machine learning project, and try to finish analog design project by 10th. If you have any doubt, one class I can take for analog design again, and I can help you where you are stuck. Okay. Let's start. So today we will see a new topic called as classification. Okay, what is classification? So let us see. So till now our results were like true or false kind of thing, right? Where we were seeing not true or false, so continuously varying signal. So till now we are seeing a continuous varying signal, where this was the this is what we had seen. Okay, so this was our program. Okay, this will changing, and this we could predict any values in between. Now what if there is some case where there are like, this is one case, true, false, yes, no. So whether a person is going to purchase a product or not, so this guy is going to purchase or not, So this is that category. Okay, so there is a product here now. Okay, there is a product. This product, uh, these many people have purchased. Okay, that product, these many people have purchased, and these many people have rejected it. Okay, so there is a plot of age. Okay, the people who are seniors are likely they have purchased, and people who are younger, it shows a trend that these people have not purchased. Okay, so similar to that, whether he is going to do this or not, whether it will be head or tail, that kind of scenario if you have, you should go with the classification. Regression is used when you want to see a continuously varying value. Okay, where numbers are continuously changing and you want to know the trend. So you have already seen some data, you can understand that part now. Okay, now there are algorithms to do classification. So regression, there were 5 to 6 algorithms. Similar to that, one algorithm is not enough for all classification or all regression. You need multiple algorithms for one type of problems. Okay, so here what we do is we try to do a regression, so that's why the name is logistic regression here. Okay, we are trying to apply regression in this case also. Okay, that's the why this is a classic example of classification where logistic regression is used. So what it does is it draws a line. Okay, straight line, and then it does this part and it does this part. Okay, so it says that here everything is 0, everything is 1, and it decides at that point. Okay, then what it does is, so these are the steps. Okay, so this is a straight line. This is that equation 1 by e power minus e that will convert the straight line into this form. Finally, what we do is we draw a line in between. Okay, and we say that 50% or 50% will draw midline. Okay, line at the midpoint, and we say whatever comes above this is yes, whatever comes below this is false. Okay, 0 or 1, like that we will say. Okay, we are going to divide this at the midpoint, and we are going to say that whatever is above this, the people will purchase, less than that we will reject. So there are chances. See, these people have actually purchased, but we are considering that we are not giving much importance to them because they are rare cases. So even this guy has purchased, but those are rare cases. So that's how we'll do classification here. Now let us see further. Finally, yes. So these are the values. Okay, that as I mentioned. So all the people. So we will draw a line at 50% here. Exact 50%. We'll draw a final line. Okay, this final line is exactly 50%. So this is that 50% line. Okay, then we will say all those guys who are crossing this point, we will consider them as 1. So all these people will be 1. All these people who are just at this boundary are considered as 0. Okay, this is how this classification logistic regression will work. So this is regression applied in classification. Okay, that's why the name logistic regression. Okay, now let us try to see an example and work on that. For this, there is an social network ad dataset. Let me see if I have that open here. Okay, so this is a social network ad. Okay, so there are like these are the ages of a person and their estimated salary. Okay, and there is one product, simple product was there. Simple, imagine a trimmer. Okay, trimmer is there. Okay, so out of these people, okay, the ad was shown to all these people on the website. Okay, when you open Google Chrome, you see there are ads, right? Now the ad was shown to people with this age this salary. Okay, now how did you get a salary from that person? That we don't know. Okay, that is just a just for you. I gave an example. Okay, so now this category, the 19-year-old having 19,000 salary did not purchase it. Here, a 32-year-old with the 1,50,000 purchased it. Then you can see 47-year-old also purchased, 45-year-old purchased, 27-year-old rare event he has also purchased. Okay, this is that big data we have got. Okay, now we have to take the columns and this thing. Okay, so what we will do? We are taking all the columns except the last column here, and here we are ignoring all columns except the last column. So this is x and y. So what will be there in x? What will be there in y? X will consist of, let me connect the charger 1 second. Okay, so x will consist of a and b. X will consist of a and b, and y will consist of c. Then we have got x and y. Next step is splitting. We already know to split this data into training set and test set. Next one is scaling. Okay, here most of the classification algorithm might need scaling. Okay, so for that we have we are scaling only the input side. Okay, because it output is already 0 or 1. Okay, that's why we will scale only the input. So SC standard scalar, then you will pass X train and you will get a new X train. So this X train is this actual X train is replaced with this train. We will get this X train here. Okay, then X train and X test also we have transformed. Okay, because we have to do the testing also. Okay, then this is the algorithm. Okay, logistic regression from linear model we will apply, and here our algorithm has got trained. Okay, so now the next step is predicting whether the person is going to purchase the item or not. Okay, so the things that you have to remember is when to apply transformation, and those things are like we have to know the algorithm. You cannot blindly work there. Okay, so this is that transformation which will convert this data into the form which in which the algorithm was trained. Okay, so this transformation we have to apply again. We cannot give 30,000, 87,000 directly because we have applied transformation here. That's why we need to apply transformation again here. Okay, sc dot transform, same sc dot transform I'm using, and I'm going to check whether a person with age 30 years with 87,000 salary, whether he is going to purchase or not. So I will run this. So the answer is 0. So this is giving an answer as 0. Now let me increase this data. Salary, sorry, age. I'll comment this. I'll increase the age and I'll increase the salary to 1,27,000. And let us see what will happen. So as expected, it is telling that he is going to purchase. So the logistic regression which was there here, that as the age increases and the salary increases, there is a high chance it is going to, that guy is going to purchase. Okay, now let us see. First I will share this data. You guys can try to run this, and I will also share the me explain now next part. So this is how you can get the basic idea. Now to there is the now we will start predicting the, see, we have done a prediction on one value. Now the test data which we had, we have not yet predicted that, so we will predict that as well. Okay, what is that prediction? See, uh, classifier dot predict x test. We have applied this directly. Here we have done transformation. Why? Already this x test was passed to a transform. Okay, this was already. I am sharing my screen, right? Okay, sorry. Okay, sorry. Yeah. See, here next step is predicting the data. Okay, so predicting, I am using predict x test. Here this x test is there, right? This one is already passed through a transform. Okay, so sc dot transform x test. So that's why here that x test is used, and we are predicting. So this is the predicted data. Okay, and similarly we will have that actual data. Okay, so y test and y pred and y test, both of them will give us the actual conclusion. Okay, we can use that and do a matrix called as confusion matrix. What is that confusion matrix? And you can also, right, first we will see what is that. There is an also an score we will get using confusion matrix. Okay, that is the accuracy score. That R2 score was used in regression. Okay, in classification we will use confusion matrix, and accuracy score we will use. Okay, okay, so here we can see it is giving us an accuracy of 89. And what is this? It is telling me that out of 65 cases for zeros, so people who have not purchased, 3 are wrong. Okay, 3 are wrong. And here out of 32 cases, out of 32 cases, people who have purchased, 24 are correct and 8 is wrong. Okay, so the accuracy is low in this case, this is high. Okay, so overall accuracy, if you see the total overall accuracy, it is like 89%. Okay, that is the overall accuracy. Now this is the way you can predict the data. I am going to share this as well on chat. Okay, next step. Now we have seen the accuracy in this form. Now there's one more way of visually seeing the accuracy. Okay, that is done using this big code. Actually, whatever we have done is more than enough, but this visualization will help you to see things in a better way. Okay, so if you have to do presentation, maybe in the college when you are doing your final internship presentation, you can add this kind of plots and you guys can show. Okay, it will take time, so there's a very big plot which is going to happen. It is taking time. Okay, let us continue. It will come up in some time. Okay. Yeah, it came up, I guess. Wait. No. Yeah, it will come. Anyways, so what this code do is, I'll explain the code slightly. Okay, it is going to do a massive big sweep. Okay, it will going to do a massive big sweep, and the plot name is called as contour. Okay, so that we are going to take x1 and x2. What is x1 and x2? X1 and x2 is nothing but the train data, and this is our x train and this is the y train. We are doing a transformation as x set and y set. Okay, then we are doing a plot where we will take so many points in between. Okay, x set and y test, the minimum of that, the minimum of x set. Okay, the plot came up. Yeah, so this is the plot. Okay, what does this signify? So this signifies that there are actually this red dots was supposed to be in this place. Okay, this place. Okay, and these green dots which are here, they should be present here. Okay, these green dots should be in the green region, red dots should be in the red region. Okay, so that is what it is telling you. Okay, and whatever red dots, you can also see some red dots here. So there are some red dots here. Okay, there are red dots here, they are actually correct, and there are some green dots here. Okay, those are also right. Okay, but there are some places which are, there are false things. Okay, so that shows how accurate visually you can say that how accurate your algorithm is. Okay, now you guys can apply it in any form. Okay, so whether a person is going to purchase a product or not, whether he is going to come or not, or India is going to win this match or not. So all this thing based on, but the input should be clean and clear. Okay, here the input was age and the salary. Okay, and based on that it is this plot. So you cannot do this plot for a massive date inputs. Okay, so as the input increases, you cannot do the plot, but you can get the confusion matrix. From there you can get the score. Okay, if there are more than two values, you cannot do the visualization plot, but you can always do the confusion matrix and get the accuracy score. So this is, it will take time to explain, but this is not important. Okay, this how, what is this, that is not important. But if you are interested and if you want to understand, let me know. I will explain this in detail sometime. But I'm going to share this complete code with you, and whatever important thing is this confusion matrix and this plotting is just for visually it is required. Let me know if you don't understand it. Okay, I'm going to share this complete code. You guys can run and check. Yeah, okay. Now next algorithm, one more algorithm we will see for today, then we'll stop. KNN algorithm. So nearest K, nearest neighbor. So what NN stands for nearest neighbors. Okay, so it is a very simple, and the approach is straightforward. Okay, it does a very nice simple approach. This is the category it will divide. Okay, so it will make some category 1, category 2, it will make that category. Okay, then if you want to predict a new category, you already know category 1 and category 2. What is category 1, category 2? Category 1 is people who have not purchased. Category 2 is people who have purchased. Those are two categories. You already know that. Now there will be a new guy. This is the new thing which you have to predict. Imagine you have to predict whether this guy with this input and this input, in the sense his age and his salary, whether he is going to purchase or not. In that case, what you will do is, wait, let me take a snapshot. Okay, in that case, what we will do, we will take the nearest lying 5 neighbors. Okay, that 5 is a number which you can have, maybe 6, 10, whatever you want, you can keep. So what we will do, we will take, you will imagine a circle. Okay, you will draw a circle with the radius of some circle with some value, and you will pick the nearest 5 points which is keeping this as the centroid. Okay, this is the center point, and you will draw a circle and you will take 5 points. Then you will see how many points are surrounding this circle more. Okay, whether it belongs to category 1 or category 2. So you can see this point is having more number of red circles near to it. So we will consider that this guy belongs to category 1. Okay, so that's how it will work. So the same thing is now explained in a flow chart. Choose the number k of neighbors. So in our case it was 5. Take the k nearest neighbor of new data point according to Euclidean distance. Okay, what is Euclidean distance? I will explain. Among the k neighbors, count the number of data points in each category. Okay, then you see how many points belongs to category 1, how many points belongs to category 2. Assign the new data point to the category where you counted the most neighbors. So as I said, if whichever side there are more neighbors, more points, that point is going to go into that region. Okay, this is simple democracy kind of thing, where you ask for voting and something similar to that. Okay, but idea is very much clean and clear. Okay, now what is that Euclidean distance is, the formula is given by this. Okay, if you want to find the distance between 2 points, you can do this. Okay, simple square root of x2 minus x1, a distance between 2 points. Okay, so here that distance, how to know which are the nearest lying points? So first what it will do, that circle is also an option. What it will do is, first it will see the distance among all the points. Okay, this one, this one, this one, this one, this one, this one, this is Euclidean distance it will take. Okay, between these points. Okay, then finally it will have a distance value for all the cases. Then the top 5 which are nearest to it, it will take those points. It will take the distance of all the points, and whichever is nearest to it, the top 5 it will take, and it will run the algorithm. Okay, so now this is the algorithm. Now we'll see the code. Okay, this code is here. It is straightforward. First step is straightforward. This is also straightforward. Next step is also straightforward, where we are doing scaling here. Okay, we are doing the scaling. So most of the classification algorithm needs scaling. Next one is, this one is going to get changed. Okay, here number of neighbors, you can change it. Okay, and what is this metric, what is this b by 2, we will come to know from if we go and see the k neighbor classifier algorithm. We will get the complete details of that. Okay, then this is also our previous thing because we had to do transformation. Now let us just see the confusion matrix and the accuracy score before doing visualization. Okay, Okay, so this is so in our previous case, what was our accuracy? 0.89% for logistic regression. What is the accuracy this guy is giving us? 93%. Okay, so it is telling us that out of 68 cases, 4 cases failed. Out of 33 cases, 3 cases failed. Okay, that is called as confusion matrix. Okay, here you can see out of 68 cases 3 failed, out of 32 cases 8 failed. Okay, so the total number is same. Okay, 32 cases, only 3 failed here, 29 pass. Now let us quickly see the plot once and then I'll share this code. So here the only thing that is changed is these two lines, sorry, these 3 lines. Okay, that's it. Okay, even this line is same, only 2 lines the code has changed. And you guys can play with this neighbors metric. You have to see what are the parameters which are there defined inside this, then you have to understand that and you have to go ahead. Okay, now I will show you the plot, then I'll share this code. Plot will take time. Let it run. By that time I will share the code. Okay, so you guys also can run this and check. I'm going to share this code. After this, a new algorithm I will not take, so you have to just go through this code now, check and let me know. Yeah, let me show the plot as well, then we can stop for the day. Hopefully you guys are trying. Okay, so this will take some time. This is a big plot. Okay, I think this will take time. I will stop the recording